So we have x squared times x cubed. When we have the same base, two bases, two exponents, what do we do to the exponents? Add them together. Yes, we do. So we put an equal sign, and it's x to the 5. So when you have two bases and two exponents, you add your exponents when you multiply. B, when you divide, you have two bases, two exponents. What do you think we're going to do with these two? Subtract. So we're going to get x to the 4. Now, if you're like, I think I multiply these, I don't know. Narrow it down with, what am I going to do with these? Everyone gets this right. What do I do with those two? X to the 5 and the 4, and they're touching. What do I do? Multiply. So if I multiply these ones, then I must add those ones. You can't do like the same operation to two totally different looking things, right? Two bases, two exponents, add. One base, two exponents, you multiply. They're side by side. This bracket basically is like a multiplication symbol. So I get x to the 20. One base, two exponents, multiply. Two bases, two exponents. They have to be the same base. You add. This one here, we have to distribute the 3 in to the numerator and the denominator. So we are going to get x to the 3 over y to the 6. Okay, this one, a lot of people err because they forget to put the 3 to the 3. So this is actually a 3 to the 3, and then you multiply it. So if I show a middle step, it would be 3 to the power of 3, x to the 6. That's 3 cubed. Nope. 3 cubed is not 9, it's 27. Because 3 cubed is 3 times 3 times 3. Okay, then in grade 10 we talked about negative exponents. So, simplify and write your answers with positive exponents. So if I have x to the negative 3, does anyone know how you can make a negative exponent positive? If it's in the numerator, you put it in the denominator. Are you choking on your own spit? Okay. Numerator goes to the denominator to make it positive. If it's negative in the denominator, it goes to the numerator. Just swap spots. Okay, so if it's in the denominator and you want it positive, move it to the numerator. If it's in the numerator and you want it positive, you move it to the denominator. That's it. So this is in the numerator. It's in the top. So I can just take it and drop it to the bottom, and it gets rid of my negative exponent. If you don't believe me, I'm going to give you an example. 4 to the negative 1. Type that baby in your calculator. 4 to the power of negative 1. Four to the power of negative 1, negative 1, negative 1. Put it in your calculator, 4 to the power of negative 1. And what do you get? 0.25. True statement. I told you, though, that if you wanted to, anything to a negative exponent in the numerator, you could just drop it to the denominator and make it positive, wouldn't it? So I can actually get 1 over 4 to the positive 1. What is that? 0.25. Proving me correct. So whenever you have a number to a negative exponent, you actually have a fraction. So if you have like 3 to the negative 1, you have a third. 4 to the negative 1 is a quarter. 2 to the negative 1 is a half. You can take that 2 to the 1 and drop negative 1, drop it to the bottom. Okay. What do I do when I multiply two things? I go 4 times 2 is 8. I really hope you all knew that and just didn't answer. Because if so, we're going back like circa grade 4. That's very scary. Okay, actually grade 3 you learned that. X cubed times x to the 4 is x to the, what am I going to do with my exponents? Yeah, negative 1, I'm going to add them. I love the whisper answering. It's so great. You are all smart and know the answers, but you all whisper answer like you don't know the answers. It's the craziest thing. Good thing when my hearing's shot, I'm going to quit. Because I won't be able to hear any answers. I can't go to any like truck rallies or anything like that if I'm wanting to, like those monster trucks. Blow my ears and I can't hear your whisper answers. So you guys have basically left me in my house. Like I can't go near loud honking. Can't use earbuds. Blow my whisper answering. You know. Does the 8 drop to the bottom? Is the 8 to the negative 1? 8 and x would have to be in brackets if it was to the negative 1. 8 is actually to the positive 1 currently, is it not? So does the 8 actually have to move anywhere? Nah. We just need to move the x down here. So we go x to the 1. So it's just 8 over x. Please don't drop your coefficient if it's not in a bracket. If I had it like this, 8x to the negative 1, guys, if this is how you had it, then that would be true to drop it as 1 over 8x. Right? Then it would make sense because the 8 would actually be to the negative 1. But you see the 8 is not included in there, in the one we did. All right. So we can go 2 to the negative 3. And then x to the what? What's 4 times negative 3? Negative 12. Now if I want, both of these actually have negative exponents, don't they? So I can drop both of them to the denominator and get positive exponents. On the denominator, I'm going to have 2 to the positive 3 and x to the positive 12. What's in my numerator if they move to the bottom? A 1. Remember, you have to have a 1 left behind if your numerator all goes away. We did that in rationals too. What's 2 cubed? 2 cubed is 8. Yes. Oh, some people actually answered. I didn't have to do anything yet. Yeah. Right here. For D, is 5x to the negative 3 or is just x to the negative 3? Just the x, right? The 5x would have to be in brackets if it was also the negative 3. So I can actually take this and drop it down here, take this and put it up here. So the 5 stays because it has nothing. It has no exponents. But the x to the negative 3 can go to the bottom, and the x to the negative 2 can go to the top as a 2. They just swap spots, right? If you move from denominator to numerator, it becomes positive. Numerator to denominator becomes positive. And now I have division. When I have division with 2 bases, I subtract. We agree? So we're going to go 2 minus 3. That's 2 minus 3. X to the negative 1. And then I have to drop it to the bottom, right? So it's 5 over x. Wow, what does this say? Your turn. What do you suppose I'm going to want you to do? Do it. It's your turn. There's a number 1, and then number 2, and 2 en français. Oh, poop. I just said poop twice. On the, So what I've decided is I stand too close to the board, it seems, and if I just stand away from it and point, it doesn't do it. So I need a meter stick to write on this board, or a really long arm. 1 and 2, work on those. Okay, a to the 5 times a to the 2 is a to the 7. No, we did this earlier. Oh, it's. Don't even know. I don't know. Okay, what about B? A to the. And yep, it's not an A. X to the 2. Okay, this one is B to the 6. This one is X to the 4. And then 2 to the 4, which is 16. You have to remember to do 2 to the 5 on this one. 2 to the 5 is 32. And then Y to the 5. All right. Number 2. So, is the 4 and the x in a bracket to the negative 3? There's not even a bracket to be found, is there? So, What is to the negative 3? Just the x. The 4 is actually just to a 1, isn't it? So is my 4 moving to the denominator? No. So I'm going to have a 4 in the numerator, and then the x3 is in the denominator, and it makes it positive. You do not have to move the x. You're trying to make it look like you're phone, but you don't. Who punches pretendingly into the back of their calculator? Okay. All right. We have 5, 15, and 5. What can we take out of both of them? A 5. Or we can go 15 divided by 5, which is 3. Either way, we end up with a 3. It's the same rule as rationals, right? So then we have to subtract our exponents. So we have 3 on the top. Then I go y to the negative 3 minus, divided by y to the 1, which is just negative 3 minus 1, which is what? Y to the negative 4. And then I can bring this to the denominator. So I get 3 over y to the 4. Okay, C. We go 3 times 5 is 15. X to the 3 times x to the negative 2. 2 bases, 2 exponents, so I add them. What's 3 plus negative 2? X to the 1. Do I have to show the 1 as the exponent, or can I just write x? And then I have y to the 1 times y to the 4 is y to the 5. Okay. Now we have 24 and 16. What can I take out of both of those? 8. 24 divided... Stand back when I do this. 24 divided by 8 is 3. 16 divided by 8 is 2. So I know I have a 3 on the in the numerator and a 2 in the denominator. And then I have division, so I have to subtract my exponents. So I go negative 8 minus a minus 3. What does that get me? Negative 8 minus a minus 3 is negative 8 plus 3, which is negative 5. And then it drops to the bottom. So I get 3 over 2 p to the 5. This one, it's just the a to the negative a third that needs to move. It's in the bottom, so I move to the top, to the numerator. And I get 2a to the positive 1/3. This one, the 3 has to go into the bracket. So I get 2 times 2 cubed is 8, x to the negative 6, which actually gives me 16 x to the negative 6. And what do I do with the x to the negative 6? Move it to the denominator. Okay, then we're flipping over and we're going halfway down page 2 and we're going to look at example 1. Yeah. You have to watch, so if like the podcast, because you're going to miss that. Okay. So, we are here at the your turn. Nope, we're not. We're at the common base. So, we have to understand example 1 really, really, really well, because it's leading you into being able to solve by common base, which is what we're doing right after this. So, Nanya, he's got hockey. He normally isn't. Yeah, he's got hockey practice. Why do I know?
Because he's got a week.
Because he's my student and I know.
I know. Usually they just say they're leaving.
He is. Okay, we have 9 to the 2x to base 3. So we have a 9 and we need it to be base 3. So it's base 9 currently. When you have a number to an exponent that is the base, then to the exponent. We were talking about that in grade 10. So We're halfway down the page on the back side. So it says 9 to the 2x to base 3. So I need 9 to be base 3. 9 is 3 to the what exponent? Three to what exponent? Yeah, thank you. 3 to the 2 is 9. And then the 2x still sits out here. Because that didn't go anywhere. And so we have 3 to the 4x. So we're just changing these to bases. Make sure you're paying attention. We're just changing these to bases, different bases. So this one now is 125, and we want to change it to base 5. 125 is 5 to the what? We're not multiplying. We want an exponent. 5 to the what? To the 3. To the 2 minus x. And then I put the 2 minus x in brackets. So if my exponent is binomial, make sure that you are distributing through. So I put it in brackets so that I make sure I distribute through. So I get 5 to the 6 minus 3x. The next one, we have 8 times 16. What you cannot do is put those together. There's going to be someone on the exponential test who is totally going to multiply these and say it's to the x. And by someone, I mean at least 25% of you, and you're going to get it wrong every single time. You cannot put those together. You can only put something together with an exponent if it's the same base, right? So like if I had 2 times 2 to the x, this is 2 to the 1, that's 2 to the x. I can put them together by addition. So I get 2 to the 1 plus x. Because they have the same base and 2 exponents. Do you agree? But if I have like 2 times 16 to the x, I cannot go 32 to the x. You cannot do that. You cannot put these together unless this is a 2 and this is a 2, which we could do. Correct? So we're going to look at this 8 and 16 to the x. I cannot put them together by 8 times 16 and put it to the power of x. But I can make them both be base 2. 8 is 2 to the what? 2 to the 3 times 16 is 2 to the 4, and then the x joins it, right? Now, because they're both the same base, I can put them together, correct? I'm going to get 2 bases that are the same, 2 exponents, I add them to the 3 plus 4x. Done. This one I have 1 over 512 to the 3x. I don't like dealing with exponents unless I'm forced to. Is there any way I can make that be 512 and not 1 over 512? Remember I told you every fraction is just a number to a negative exponent, is it not? So like a quarter is 4 to the negative 1. A half is 2 to the negative 1. So 1 over 512, I can just bring this whole thing up here. And because this is a 1 up here, I'm just multiplying by 1. So this would be 1 times 512 to the negative 3x. Does 1 times anything do anything? No. So this is technically just 512 to the negative 3x. And they want it to be base 2. 2 to the what is 512? Try that out. Someone said it. 9. 2 to the 9 is 512. And then that's a negative 3x. So it's going to be 2 to the negative 27x. You dented the can exactly where you used to drink.
Doesn't even work.
Oh no. Now E, people think is actually going to be really difficult. It's not. I have 16 over 81 to the x plus 5, and it needs to be a base 2/3. What I can do is, I know it needs to be 2/3 to the something. So I look here and I say the 16 has to come from 2, and the 3 has to, or 81 has to come from 3. 2 to the what is 16? 4. Is 3 to the 4 also 81? If I distribute this 4 through, do I get 16 over 81? 2 to the 4 is 16. 3 to the 4 is 81. So I can write the whole thing to the 4, because both of them actually to the 4 get you the previous. But I still have to raise that to x plus 5. So I'm going to get 2/3 to the 4x plus 1. Ah, what's this here? Might it be your turn? It is. There are 4 here, and then on the top of the next page there are 3. Get working. Because I want to go through a couple common base questions too. Okay, so this one, everyone's paying attention? We have 32x, and we need it to be base 2. 32 is 2 to the what? 2 to the 5. And still outside the brackets then is x. That's supposed to be the same height. Sorry. So it's 2 to the 5x. 1,000, if we want to write it as a base 10. So we're going to just replace the 1,000 here with 10 to the what? 10 to the 3. And then outside the bracket is still 2x plus 1. I have to distribute. So I get 10 to the 6x plus 3. Then this one, I need 81 to be base 3. 81 is 3 to the what? 3 to the 4. And then x minus 2. Then we distribute. So we get 3 to the 4x minus 8. And then here we have 1 over 64. And then I told you that whenever you have 1 to the something, you can just draw that up and make it to the negative. So it'd be 64 to the negative 2x. And then replace the 64 with 4 to the what? 3. So I get 4 to the negative 6x. And then we're flipping over. This one, we have 2 times 4. We want them to be base 2. So we don't write 8 to the x. Please don't do that. If you wrote 8 to the x, star this one, because you're going to be doing it wrong every single time. I can tell you that right now. It's not 8 to the x. This is 2 to the 1. And then 4 is 2 to the 2 to the x. So it's going to be 2 to the 1 times 2 to the 2x. And we have 2 bases that are the same 2 exponents we add. So we get 2 to the 1 plus 2x. The next one, we want them to be base 3s. 9 and 27, we do not multiply together. We say 9 is 3 squared. 27 is 3 cubed. But it's to the x minus 1. So we're going to get 3 to the 2 times 3 to the 3x minus 3. Now we have the same base. So what do we do with the exponents? We add them. Bless you. So we're going to get 3 to the 2 plus 3x minus 3. And then we can collect like terms. So we get 3 to the 3x. 2 minus 3 is negative 1. L, we have a quarter and then 1 over 16. And we could change those. A quarter we can write as 4 to the negative 1. And then we're going to multiply that by 16 to the negative 1. And then 4 minus x. You can distribute that through. So I get 4 to the negative 1 times 16 to the negative 4 plus x. And then I change 16 as 4 to the what? 16 is 4 to the 2. Yeah. So we get 4 to the negative 1 times 4 to the 2. And so we get 4 to the negative 1 times 4 to the negative 8 plus 2x. And now we have the same base, so we can put them together. And we get 4 to the negative 1 plus negative 8 plus 2x, which is 4 to the negative 9 plus 2x. Now, why are we doing this? We're doing this to solve exponential equations. So whenever we have variables in the exponent in the past, if you were in -1, 20-1, you would have used it in geometric. If you're in 20-2, you haven't even really had to solve for exponentials. But the problem is that our x is in the exponent. We don't know how to solve stuff like that. We know how to solve like 4x plus 7 equals 2. Add the 7, or minus the 7 over and divide by 4. Like, we're good with linear stuff, right? We can even do quadratic. Move it all to one side, put in the quadratic formula. We can do that too. But exponential is a bit hard. So what you actually have to do is you have to try and get this so we don't actually have to deal with solving it as an exponent. We want to solve it like we would previous. So, side note, if I gave you this, if I said, whatever, if I said 5 to the smiley face equals 5 to the x, what would you tell me x has to equal? Smiley face. This is a true statement. If 5 to the smiley face equals 5 to the x, well, x would have to equal smiley face if that's true. Because this would have to be the same as this, because these are the same. Correct? So if I can make my bases be the same, if I can have one base on one side be the same as the other base on the other side, then my exponents can just equal, and I don't have to deal with the fact that they're in an exponent. So let's look at this first one. It says solve. So if you have to solve, I'm expecting x equals a number at the end boxed, right? Or extraneous roots canceled off, stuff like that. That's what solve always is in math. So here, if I have 5 to the 2x plus 3 equals 5 to the 7, my bases are the same. So if my bases are the same, I can say that, well, then if that's true, then this must equal that. Is that not a true statement? If they're both base 5, do those exponents not have to equal in order for that to be true? If it's 5 to the something equals 5 to the something, then this 2x plus 3 must equal 7, correct? So some people cross off the bases. They think the bases go away like that. The bases aren't going away. You're not crossing them off. You're just saying, I don't need the bases. If this is 5 to this exponent is 5 to this exponent, then 2x plus 3 must equal 7. So you can drop the bases completely off and just set the exponents equal. Like I did up here. I had, well, okay, well then smiley face must equal x. Okay, well then 2x plus 3 must equal 7 if they're both base 5. If one of them is base 25 and the other one is base 625, I can't do that. Correct? Because they're totally different bases. So my first goal is to make both sides have the same base so I can set the exponents equal. And now I just go back to normal junior high solving. I subtract 3. I get 2x equals 4. Divide by 2. X equals 2. And I can check it. If I put the 2 back in, I get 2 times 2 plus 3, which is 7. 5 to the 7 equals 5 to the 7. True statement, isn't it? So I box it and I'm right. The next one, what base can I make them both be? 49 and 343. Anyone have any idea? The 49 should ring a bell. What's something that can be squared? Yeah. So 49 is 7 squared to the x minus 2. 343 has to also be base 7 then. 7 to what exponent? Typing in your calculator. 7 to the 2, 7 to the 3, 7 to the 4, 7 to the 5. 7 to the what is 343? 7 to what exponent is 343? You okay? Choked on your own spit? I have a gift I thought I only had, but means other people have. 343 is 7 cubed. So then I have to distribute this through. So I get 7 to the 2x minus 4 equals 7 to the 3. If this is a true statement, I can then say that this must equal this, correct? I can say that the exponents have to be equal in order for left side to be equal to right side. So now I can just drop off the bases, and really what I'm doing is setting my exponents equal. I can go 2x minus 4 equals 3. Add the 4 over. 2x equals 7. And I divide my 2, so I get x equals 7 over 2. And if I go 3.5 minus 2, I get 1.5. 49 to the 1.5 is 343. Your homework is this. What base can I make them both be? Chose a smaller base, not a large base. What base can I both make them be? 3 and 81. I'm guessing 3, since 3 is small and I can't make it be anything else, so I'm guessing I can make them both be 3. 81 is 3 to the what? 3 to the 4. So do that one.